Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice exponential problem, and here we have 27 to the power of n minus 3 to the power of n over 9 to the power of n minus 3 to the power of n is equals to 82, and we will solve this problem for the value of n. So the very first thing we are going to do is, here first I can rewrite this equation as, here you have 27 and we will write it as 3 times of 9 and its power n minus 3 to the power of n whole over, here you have 9 and we will write it as 3 times of 3 to the power of n minus 3 to the power of n is equals to 82. And now we can use a nice exponential law here. So you know about this law, if we have a times of b to the power of n, it is equals to a to the power of n times of b to the power of n. We will use here this nice law. So according to this law, this term will be rewritten as in the form of 3 to the power of n minus 9 to the power of n, times 9 to the power of n minus 3 to the power of n over, here we again separate this exponent and you get 3 to the power of n times of 3 to the power of n minus 3 to the power of n is equals to 82. And now you focus on the up and down side and you see that here you have 3 to the power of n is a common term, so that we will take common 3 to the power of n and you get 9 to the power of n minus 3 to the power of n whole over, here again we take common 3 to the power of n, here you get only 1 because here we take common 3 to the power of n. Similarly, here you take common 3 to the power of n and you get 3 to the power of n minus 1 is equals to 82. And now you see that this 3 to the power of n is gone and you get the remaining terms in the form of 9 to the power of n, and here we will write this 9 as 3 squared. We can write 3 squared and its power 9 minus 1 and whole over, you have 3 to the power of n minus 1. And now you can simplify the term. So here you have 3 squared to the power of n. And now you can multiply, or you can again apply the nice exponential law here, and you know that if we have a to the power of m and its power n, it is equals to a to the power of n to the power of m is equals to a to the power of m times of n. This exponential law states that, or tells us that, if you can interchange these two exponents, it cannot be affect to the final answer. So that here we need to interchange these two exponents, so that if you can interchange these two exponents, then you can get the resulting answer in the form of, here you have 82. So that now we will interchange these two exponents according to this law and you get 3 to the power of n and its whole squared minus, here you have 1 and we will write it as 1 squared and whole over, you have 3 to the power of n minus 1 is equals to 82. And now you focus on the upside term, and here you see that we have a squared minus b squared. It is the nice square identity, and you know that if we have a squared minus b squared, it is equals to a minus b times of a plus b. So now we apply this nice identity in the upper term, so that this term will be written as in the form of 3 to the power of n minus 1 times of 3 to the power of n plus 1 and whole over 3 to the power of n minus 1 is equals to 82. And now you see that 3 to the power of n minus 1 is the common term from up and down side, so these are gone, and you get the term in the form of 3 to the power of n plus 1 is equals to 82. And the next step is we will move this plus 1 to the right hand side. So here it is plus 1. When we move in the right hand side, it will becomes minus 1, and you get 3 to the power of n is equals to 82 minus 1, and 82 minus 1 is equals to 81. So now you focus on the right hand side, and here we have 81. So in the next step is that we will now we focus on the right hand side, and here we have 81, and we will find the prime factors of 81, and the prime factors of 81 are 3 to the power of n is equals to 3 to the power of 4. So now you focus on both of the sides, and we will use this exponential law. If we have a to the power of m is equals to a to the power of n, this implies that m is equals to n. So if you have bases on both of the sides are same, so that its exponents are equals to each other, so that when you compare both of the sides, then you will get the value of n is equals to 4 according to this exponential law. So now n is equal to 4 be the only one solution of the given question, and this is the our final answer. So thank you so much for watching this video. Please subscribe to my channel for more exciting video.